First, a brief introduction to ESP32. ESP is a brand name for a series of wireless system-on-chip products from a company called Espressif. These embedded system-on-chips are quite attractive for IoT applications because they come with integrated support for wireless connectivity technologies such as Wi-Fi, Bluetooth Classic, as well as Bluetooth Low Energy. There are three series of ESP products: the ESP8266, the ESP32, and the latest addition to this family is ESP32S. In this startup guide, we'll be focusing on the ESP32. ESP32 has support for Wi-Fi, Bluetooth Classic, as well as Bluetooth Low Energy. It has a low power consumption, and it has quite rich support for various peripherals. There are multiple ESP32 product variants. You can find the complete list of available variants from Espressif's product website. There are single or dual core variants, as well as with or without embedded flash memory. Before we start exploring ESP32 application development, we need to have first a development board on hand. The list of available development boards can be found from Espressif's product website. You can order one from your preferred hardware distributor for about $10 to $15. In this startup guide, I'll be using the ESP32 Pico kit. However, the information in this guide is equally applicable irrespective of the type of ESP32 board you are using. In the rest of this video, I will walk you through how to set up the software development environments in Windows operating system, and then we will build the example Hello World projects, and finally we flash it and run it on the ESP32 board. Setting up the ESP32 development environment requires installing various tools such as Python, Git, CMake, as well as cross-compiler toolchain. In Windows system, the easiest way to install all required tools is to use the ESP-IDF tools installer. You can follow this link shown on the screen to download the installer. Depending on the speed of your internet connection, it may take several minutes to complete the download. Once the download is completed, double-click the executable file to start the installer. This installer is all what we need to set up our environment in just one go. The installation wizard assists you to select the installation directories as well as the versions of the tools to be installed. The default settings are mostly sufficient, but depending on your system, you can configure the installation to your preference. First, scroll down to read the license agreements, and if you accept, just press next to proceed. The installer first scans your system for existing Python installations. Then it shall give you the option to install a newer version or use one of the existing installed versions. In the next step, it scans the system for existing Git installations. Here also you can either choose for a newer Git installation or select one of the installed versions. The next step is to select the version of the ESP-IDF to download, as well as the location of the installation. ESP-IDF stands for ESP IoT Development Framework. This is the official ESP development framework from Espressif. It contains everything like the software libraries, example ESP projects, as well as different utility tools and scripts. The next step, you should select the installation directory for the cross-compiler toolchain. The next step, which is I think the last one, we select additional tasks such as the option to create desktop shortcuts for the ESP-IDF command prompt. Finally, revise your selections, and if you are satisfied with your configuration, hit the install button to start the installation. The installer downloads, extracts, and installs all required tools. In reality, this may take several minutes. In this video, I will just fast forward it to the end of the installation. Now, let's check what's installed. The installer creates a shortcut in the start menu. It's called the ESP-IDF command prompt. What this shortcut does is it opens the command prompt and runs a script to set up all required environment variables from your installation. Basically, we need three things to start writing application for the ESP32. First, we need a cross-compiler toolchain. Second, we need build tools such as CMake and Ninja. And third, we need the ESP-IDF, which is a software development framework that contains the libraries and source code to write ESP applications, as well as it has various scripts to operate the toolchain. Then the command prompt script, I think it's called export.bat. It's located in the IDF path. That script checks if all these requirements are in place. So what the script does is it checks the Python installation, checks the Git installation, and then it sets up the IDF path environment variable, which points to the location of the ESP-IDF software framework installation. It then adds the required build tools to the path environment variable. In my system, these tools, the cross-compiler tools, are installed in my user profiles directory in the Espressive subdirectory. So if all requirements are satisfied, then you should see a message that says you are ready to compile ESP32 projects. Another thing we need to check is the IDF path itself, which points to the ESP-IDF installation directory. As I said, this directory contains everything we need to work on the ESP32 projects. So here we have the components directory, which has different utility drivers, libraries, and source code we need to write our applications with. Then here you have the examples directory, which contains example projects. That could be a good starting point for learning ESP application development, as well as for starting our own new projects. Then here we have the tools directory, which contains many useful tools and scripts to build, debug, flash, and test our applications. And now our software development environment is ready. Let's take a look at the Hello World example application, which we will soon build and flash to the device. The application comes with our ESP-IDF installation in the examples directory. It's a simple app that starts a FreeRTOS task and prints some chip information. Then it restarts after 10 seconds and it will do the same thing again. The ESP chip info, this is a structure that represents information about the chip, such as the number of cores, whether the chip has embedded flash or not, or whether the chip supports Wi-Fi, Bluetooth, and Bluetooth Low Energy. The ESP chip info function retrieves the chip information, and then here the chip information is printed. After that, we count for 10 seconds and restart the device. To build the Hello World app, follow the next steps. Step 1, Start the ESP-IDF command prompt from the desktop shortcut. Step 2, create a workspace directory. In my system, I created a directory named SP under my user profiles directory. Step 3, copy the Hello World example project from the IDF path to your workspace. You can use the command shown on the screen here at step 3 for this purpose. What this command does is it just copies the project into a separate Hello World directory in your workspace. Step 4, connect your ESP32 board to your computer and then find the assigned comport name. You can use either a Windows Device Manager or another serial terminal program to find the comport name. We need to know the comport name for the coming steps when we flash and monitor the running application. Step 5, switch to the Hello World directory in your workspace, and then finally use the command shown at step 6 here to compile the application. The build command will compile the application and all ESP-IDF components, and then it will generate the bootloader, partition table, and the application binaries. Normally, the compilation will take several minutes, but in this video, I'll just fast forward it to the end. You can follow the build log to see if the binaries are successfully generated, or even you can browse to the build directory inside the Hello World directory in your workspace to see the generated bin files. So the bootloader.bin, the partition.bin, and the hello world.bin files. To flash the generated binaries to the device, use the command shown on the screen. You need to replace the port argument with your board's comport name, which you identified in the previous step using Windows Device Manager or another serial terminal program. To check if the Hello World application is indeed running on the device, type this command shown on the screen. This command launches the IDF monitor application, which is a serial output monitoring tool. It's located in the IDF path directory. After the startup banner and diagnostic logs, you should see Hello World printed out by the application. And then the application counts for 10 seconds and restarts again. To exit the monitor app, just press the Ctrl plus the closing square brackets as shown on the screen. Well, this concludes this short ESP32 startup guide video. You can further learn about ESP32 applications by exploring other example projects from your IDF installation directory. You can also visit the official API documentation website as well as the ESP32 forum for specific questions or even general discussions.